Integration by partial fraction decomposition. You're going to find that the algebra of this is harder than the calculus, which you might have said in the past. There are lots more places where we can make a mistake in the algebra, I think. So the first step would be to figure out if we need to divide. It's not improper. 2 is smaller than 3 for the degree, so we don't want to divide. So the next step would be to see if we can factor the denominator. Now, x cubed, x squared, x, they all have a common factor of x, so we factor that. And what's left is, turns out, a perfect square trinomial. It's x plus 1 squared. So we have our original fraction with the denominator in factored form is equal to a over x plus b over x plus 1 plus c over x plus 1 squared. Remember to repeat the repeated factor, it gets repeated fractions. So we're going to defractionate this by multiplying both sides by that denominator of x plus 1, or x times x plus 1 squared, x times x plus 1 squared. And that's going to get rid of all of the fractions and give us a cleaner equation to work with. A over x, the x's cancel out, so we have a times x plus 1 squared. For the b fraction, the x plus 1 cancels out. We still have an x. We still have another x plus 1 because there were two and one of them canceled out. And then for c, the x plus 1s cancel out, but the x sticks around. So expanding this out, we get ax squared plus 2ax plus a. That's this expanded out. Bx squared plus bx, that's this expanded out, and this needs no expanding. And then we can regroup this. We've got ax squared plus bx squared, so a plus b x squared. We've got 2ax, and we've got bx and cx, so 2a plus b plus c is all being multiplied by x. And then the only constant we have is a. That's equal to 5x squared plus 20x plus 6. So a plus b equals 5. 2a plus b plus c equals 20. And then mercifully, a equals 6. That's very nice because that means that if 6 plus b equals 5, then b equals -1. And if 2a plus b plus c equals 20, well, that's 12 minus 1, or 11, plus c equals 20. So c equals 9, because 11 plus 9 equals 20. So that is the, those are the three numerators for our partial fraction decomposition. So we've got that original integrand can turn into three simpler problems. We've got a over x plus b over x plus 1 plus c over x plus 1 squared, just replacing a, b, and c with the values that we just found. This is an antiderivative using natural logs. This is another antiderivative using natural logs. And this does not require natural logs because this is a degree of 2, right? So our degree bumps up by 1. So -2 bumps up to -1. And then we divide by our original, or no, our new exponent. And we don't have to worry about u substitution because the derivative of x plus 1 is just 1. So we could leave it like that. Probably we would at the very least rewrite this as -9 over x plus 1. And if we feel like it, a lot of people like to do this. You don't have to. But you can condense this. Just be careful. The 6 needs to be turned into an exponent before condensing. So this would be x to the 6 rather, in the numerator, and then the minus means it goes to the denominator of x plus 1. There we go. And I kind of like that as a final answer. But you don't have to condense. You can leave it as two separate natural log terms along with the fraction. And then we move on to this next one. Going to work pretty much the same way. This one we're introducing a non-reducible quadratic factor. So that's going to change the partial fraction side of it a little bit. But the concept is still that we try to break down this mega fraction into easier to digest fractions. So we've got a denominator of x, we've got a denominator of x minus 1, and we've got a denominator of x squared plus 4. So we've got a constant, and we can't put a constant here. We could have as many as 2 terms up here, a linear and a constant. So we actually have 4 different unknowns here. Good times. All right, so when we defractionate this, multiply it by x times x minus 1 times x squared plus 4. This becomes just the numerator. The a gets multiplied by everything but the x, so x minus 1 times x squared plus 4. The b gets multiplied by everything but the x minus 1, so that's x and x squared plus 4. And then the cx plus d, you got it. It's got to go in parentheses, gets multiplied by everything except the x squared plus 4. So it gets multiplied by the x and the x minus 1. Let's go ahead and multiply those together and get x squared minus x. That'll make it a little bit nicer. So yeah, we got to expand it out, right? We've got x cubed times a, which is ax cubed. Our x squared term is negative x squared, so it's negative a x squared. Our x term is 4x, so this is 4ax. And then our constant is negative 4, so negative 4a. This is a little bit nicer. It's just one distribution. Bx times x squared is bx cubed. Bx times 4 is 4bx. And now we've got this mess. So cx times x squared is cx cubed. Cx times negative x is negative cx squared. D times x squared. And d times negative x. Running out of space. All right. So grouping these together, we've got what gets multiplied by x cubed. Well, we've got an a, and we've got a b, and we've got a c. But d is not multiplied by x cubed. All right. What gets multiplied by x squared? We've got a negative a, and we've got a negative c, and we've got a positive d that are all being multiplied by x squared. Now let's go for the x terms. We've got a 4a. Wait, this negative 4a isn't. No, that's positive 4a. Negative 4a is the constant. We got a 4b. And we've got a minus d. And mercifully, there's only one constant. That's negative 4a. So 2x cubed, 0x squared, negative 4x, and negative 8 for the constant. All right, so that's good. So that means that if negative 4a equals negative 8, then a must equal 2. So that's better, I guess. So that means that instead of a plus b plus c equals 2, it's 2 plus b plus c equals 2, or b plus c equals 0. We've got negative 2 minus c plus d equals 0. So I'll add the 2 to the other side and get negative c plus d equals 2. And on our last equation, we've got 2 times 4 is 8 that we can subtract from the negative 4 to get negative 12. We're left with 4b minus d. 4b minus d. So we've got 3 variables, 3 equations. We could use matrices for this if you want to pull out your calculator and refresh your memory on solving systems using matrices. Or we can play around with these. There's not so much problem here, right? For example, if we decide to add these two together, the c and the negative c cancel out. Oh, wait a second, I messed up here. This should be a 2, shouldn't it? We added 2 to the other side, so 2 plus 0 is 2. I think I said that, but then I wrote the wrong thing. So yeah, when we add these together, the c and the minus c get canceled out, but the b plus d is still there. b plus d is equal to 0 plus 2. And that's going to be an equation that we can solve with the 4b minus d equals negative 12, because if we add these together, we get 5b equals negative 10, or b equals negative 2. So we've got a equals 2, b equals negative 2. Wait a second, if we know b, we can find d very easily. D has to equal 4, because negative 2 plus 4 equals 2. And then if d equals 4, then 4 minus 2 equals c, so c equals 2. So that gives us all the different pieces we need. Don't get lost in the algebra. You can use matrices if that's going to help you out. I'm fine with that. A over x plus b over x minus 1 plus cx plus d over x squared plus 4. Now, the first two were no problem. 2 natural log the absolute value of x minus 2 natural log the absolute value of x minus 1. This is a bit more of a problem because you're thinking, oh, maybe we're going to do u substitution, but if we do u substitution, the x squared plus 4 differentiates to 2x. And then we got that extra plus 4. So let's break this into two integrals. One is going to be 2x over x squared plus 4. And the other one's going to be 4 over x squared plus 4. So that first integral is definitely a u sub. And if we let u equal the denominator, then du is going to equal the numerator. So that works out pretty nicely. It's just going to be 1 natural log the absolute value of x squared plus 4. And then this is going to be an arctan problem, right? Where a equals x, where a equals 2 and u equals x. So 4 times 1 over a is going to be 2 times the arctan of u over a, x over 2. Gosh. Who would have expected arctan to show up here? So that's an acceptable answer. Or if you feel like playing around with the condensing, that's always a little bit fun. We have in the numerator, we've got x squared and we've got x squared plus 4, because those are positive terms. Our negative term is x minus 1 squared. Oops, that's not what I said. So let's write what I said, x minus 1 squared. And then the arctan, obviously, I hope that's obvious, doesn't condense into a natural log. So that's an acceptable final answer as well. So either one, either or, whatever you prefer.